Welcome everyone, my name is Müller, and in this presentation I'll be presenting our paper SpatialProto, a system which enables rapid prototyping of spatial and interactive experiences using real-world captures and a depth sensing capable mixed reality headset. This work has been done at the Code Research Institute and in collaboration with Ken Pfeuffer, Sarah Prange, Florian Jan Gugenheimer and Bastian Pfleging. What we're seeing here is our system in action, showcasing a little prototype to explore different variations of highlighting a doorknob. The user wearing a mixed reality headset can see animated, interactive, and three-dimensional captures. All these animations were created by recording simple everyday objects such as paper, clay, or real-world interactions from the user's perspectives, and they were extracted using our pipeline. To better understand why we developed SpatialProto, let's slip into the shoes of an HCI designer who might want to create an interactive and spatial prototype as head-mounted displays that blend virtual and real worlds are become more and more ubiquitous. However, creating such a prototype is a non-trivial task. If we assume that our designer is not an expert in mixed reality and has no in-depth programming knowledge or experience with 3D animation. As such, popular game engines like Unity and Unreal are not an option. SpatialProto, on the other hand, requires no programming skills or experience with 3D animation, and allows users to quickly create animations by recording things as they happen in front of them. While there are some dedicated tools on the market and in research that do enable non-expert users to create mixed reality prototypes, they suffer from a couple of drawbacks. For one, many tools require a constant context switch between a normal screen and the mixed reality world, resulting in a cumbersome prototyping process and reduced immersion during prototyping. SpatialProto is fully embedded in a singular immersive mixed reality experience. Finally, many systems that do support MR and MR prototyping require an extensive room setup, meaning that these systems can't be used mobile. SpatialProto uses only off-the-shelf components, such as a VR headset, a mixed reality capable depth sensing camera, and a decent computer. By using a VR backpack PC and an inside-out tracking head-mounted display, you are even able to make our system fully mobile. To summarize, the aim of SpatialProto is simple: to lower the barrier for spatial prototyping and to allow non-expert users to quickly create mixed reality experiences within mixed reality. Let's now talk a little bit more about the functionality and workflow of SpatialProto. We will showcase how a designer created part of this highlighting prototype we saw at the beginning, in this case the animated arrow. After a designer has come up with an idea for a prototype and animation, they go through the 3 stages of the SpatialProto pipeline: recording, editing, and prototyping. In the first phase of the recording, the designer can record the full view in 3D. We allow users to record in single frames, continuous video, or in a stop-motion approach. And in this example, we have created an arrow out of clay which we record in front of a red screen. Now that we have recorded our animation, we can begin the process of editing. As the system records everything the user sees, we need to remove the background and unwanted elements from our capture. This is done by various methods of masking, such as chroma keying, which we can see in the video. Additionally, the object can also be automatically segmented by using the depth information or by using object detection with convolutional neural networks such as YOLO. If we want, we can also apply image effects such as a hue shift on our recording to easily create different variations of the same animation. Finally, the designer now has the freedom to position, rotate, and scale the animation freely in the room. They can also set up interaction triggers, which trigger the playback of an animation once a controller or the head of the user collides with it. For more advanced prototypes, the designer also has the ability to group and chain interactions together to create more complex interactions. Here are a couple of example animations that were created as part of a user study. Participants managed to create these animations in under 20 minutes and were able to familiarize themselves with the system quickly, even though they had little to no experience with mixed reality or prototyping. We end this presentation with a glimpse at the example applications we built ourselves using SpatialProto. In this first example, we can see a spatial task support prototype, showing a user how to solve a Rubik's Cube in 3D. In the next example, we can see a more advanced prototype in the form of an interactive mixed reality game. Here, the user needs to place a real-world element in the right spot to open a curtain. They then face a component they need to hit before the next puzzle appears in the room. We made use of grouping and chaining interactions together to create this small narrative. Alright, thanks very much for listening, and if you do have any questions, feel free to ask them now.